Hey, welcome aboard, everybody. Gonna play around with some glow sticks here. I'll show you this. Here, let's watch this. I'm gonna turn those glow sticks on and off at will. They're on, and now they're off. And now they're on, and now they're off. You can probably hear something clicking in the background. How you doing there, Pack Slap? On, off, on, off, on, off. So yeah, it looks like, right? It looks like they're dead glow sticks. Like there's nothing to them. And then I can like turn them on if I want to. How you doing there, AE Master? UV light, that's right. I mean, that's exactly it. That's exactly it. That's exactly how glow sticks get their color, is from ultraviolet light. And that's all I'm doing. There are different fluorescent dyes in the glow. See, here's the UV light. Actually, it's not UV. Well, it's like on the board. It's like 395 nanometers. So yeah, there's just fluorescent dyes in the glow stick. And when there's a chemical reaction happening in the glow stick, that gives energy to the fluorescent dyes that are contained in the glow stick. And then those fluorescent dyes gives off color, as different colors of light. Just like different markers have, different colors. Different glow sticks have different colors as well. We're going to play around with this a little bit. Let's play around with some glow sticks and show you some stuff. All right, let's see. What are we going to do here? I don't know. Which one am I going to take? Give me a second here. Let me find let's look at this glow stick here. It's like this one doesn't even look like it has a dye in it. How you doing there, King Kong? How you doing there? This glow stick does not even look like it has a dye, right? It looks colorless. But we can tell by shining the UV light on it. Let's give it some energy with some UV. And we can see it's going to be blue, right? You can totally see that when this particular dye, whatever it happens to be, when that particular dye in the glow stick gains energy, it's going to give off energy as blue light. So let's see. Let's just get it glowing and see what happens. So let's go ahead and snap it. Oh, yeah. And of course, so it doesn't matter whether the light comes from, the energy comes from the chemical reaction or whether it comes from ultraviolet light. This particular dye that's contained in the glow stick gives off blue colored light. That's right. That is right. Hey, we got someone bright and early in the morning in India. Welcome, Aslima. Hello, Iskra. No, I don't have any sodium to throw in water. I have sodium ion to throw in water, but no sodium metal. All right, let's extract this stuff. So okay, I'm gonna go ahead. I'm gonna cut this glow stick open using a pair of PVC cutters. Hello there, Aslima. Hello there, Cora. All right, we got that baby open. I do have calcium, just not here in my home. That I keep in the lab. So I'm not going to mess with calcium metal at my house. Calcium ion I got plenty of course. All right. So now we've got our glow stick stuff. What am I going to do with it? Well, I think I want to try to extract a dye from this stuff. Anybody would know what dye I might want to extract from green tea? Drop it in the comments if you know. Let's go ahead and get the green tea open. What dye might I extract from green tea? Any ideas? Well, what I'm going to do is I'm going to try to change the color of that blue glow stick you see there in the back. We're going to try to change it to a different color. So yeah, I have some green tea bag, and I'm going to extract a dye from it. The question is, what dye will I be extracting from this bag of Bigelow green tea? Let's find out. Let's find out. I'm going to take my beaker here. So people are loving some green tea. It's a Turkish drink. Interesting. I have green tea every morning. So this is some acetone that I'm pouring into the beaker. All right. And now, this isn't the way we normally steep tea. Of course, we steep tea in hot water. But I'm going to steep this tea in some acetone. So in it goes the tea bag. Let's swirl it around. I notice a color change. Do you? Tell me what color you see. What color am I extracting? The blue molecule that's in here, the molecule that's giving off blue light, that is not a copper-based molecule. Hello there, Sapros. Come on, man. What color are we extracting into the acetone here? Any takers? What do you think? Well, I'm seeing green. I'm going to go ahead and have to answer for y'all. I'm seeing a green color. Any ideas what that green color might be? It is chlorophyll. It's the stuff that gives plants their green color, all right? So I've extracted some chlorophyll from, it looks greenish brown. So there's probably some other compounds in addition to chlorophyll that I have extracted into the acetone, but mostly, that beautiful green color that we see, that's going to be mostly chlorophyll, okay? That's what I'm seeing. Chlorophyll, baby. Little chlorophyll in there. All right, let me take the tea bag out. We might use a little bit more of that later. So the blue thing back there is a glow stick football. Can we use it to dye things? Yeah, if we know what we're doing. We're going to try, let's mix. We're going to try to color that blue glow stick back here, okay? That's what we're going to do. This, by the way, I don't know if this is going to work, but I did something we're going to mix it, AE Master. You got to give me a little time here. So the experiment I'm doing today is very similar to the new short that I put out on Saturday, if you want to check that out. Okay, here we go. So now what I'm going to do, let's take this away. I'm now going to shine the UV light onto our extracted chlorophyll mixture. You ready? Here we go. UV light. Come on, baby. Come on now. Look at that. Isn't that cool? Isn't that cool? Chlorophyll, when it gains energy, it glows like a reddish color. Now, I'm used to chlorophyll, just looking red. I'm also seeing an orange color. And what that tells me is that in addition to the chlorophyll fluorescing, I can see the red. There's also like something that's fluorescing orange. I do not know what that orange fluorescing compound is. I know the red that we're seeing is from chlorophyll. So let's just look at the color of this stuff. Isn't that cool? Like in normal light, it's green, man. And then let's see if we can see it in room lights. Now you can't see it, but if I turn the lights off, you can see that it fluoresces like a yellowish green color. It's beautiful. Excuse me, a yellowish red color. And now what we're going to do, remember I told you that glow stick fluid gets its color from a fluorescent dye that they put in there. So that particular glow stick that's glowing blue right now, it's gaining energy. There's a dye in there that's gaining energy from a chemical reaction that goes on in the glow stick fluid. And that chemical energy from the chemical reaction is gained by the dye that's present in here, and that gives it off as blue light. And AE Master, here we go. AE Master wants me to mix it, so that's what we're going to do. And notice this will change the dye that's in the presence of the glow stick fluid. And it looks like a dud, doesn't it? It looks like a dud, but I'm going to try to help it out. There it is, a little swirl. Come on, baby. I'm seeing a red tint to that. Now, I think I can make this a little better. There's just a little red tint to it. And that tells us that the chlorophyll is indeed fluorescing. I want to make it better, and the way I'm going to do that is I'm going to add a catalyst. This is a base catalyzed reaction, so I'm going to add some superwashing soda, and that should kick things off a little bit better. Let's see. Let's see if we can get the red going a little better. Just pour some superwashing soda in there, see if we can't kick off the reaction just a bit more. Look at that. Now it's kicking off. We got a little bit of pink glow. Little bit of pink glow. Because I added the base, which catalyzes or speeds up the chemical reaction, we can see that beautiful pink fluorescence from the chlorophyll. Now it looks kind of purple. It looks kind of purple because, there's also some blue fluorescence coming from the compound that's already present in the light stick. Wait, how did it turn from blue to pink? How did it turn from blue to pink? Let me turn the lights back on. Okay, so it turned from blue to pink because I started, let me get one here. I started with a blue glow stick. In a blue glow stick, there's a dye in here that when it gains chemical energy, it fluoresces blue light. But chlorophyll fluoresces red light. So when I mixed the glow stick fluid into this, the chlorophyll that was in here gained the energy from the light stick reaction and gave off red light, in addition to the blue that was already present. Let's go ahead and try to, let's do this one too. Let's pop this in here and see what we're getting. Looks like the chlorophyll, yeah, no, that still looks a little bit red to me. Still looks a little red. Let's get this glow stick going. Pop it in there. Thank you there, AE Master. Here we go. Oh, that is really gorgeous, isn't it? Look at that. It's like an eerie chemiluminescent glow. But now we're going to drop it into some chlorophyll, okay? A chlorophyll solution. And let's see what happens. No, let me add a little bit of base to this first. So make sure we got enough. We really want this to pop. All right, that's going to catalyze the reaction. And now I'm going to pop this stuff in there. After I open it, let's get her open first. Cut open the lid with my PVC cutters. Here, let me turn it this way. You can see what's going on a little bit better. All right, so I'm going to cut open the glow stick. Hello, Sebastian. What I am making is I have taken a blue glow stick, and in this fluid here, I extracted just the stuff from green tea. What I really wanted from the green tea is chlorophyll, because chlorophyll fluoresces red. So what I'm hoping is that when I pour that blue glow stick fluid into basically the chlorophyll extract, we should see a shift to a more pinkish fluorescence. Here we go. Get her on in there. I can see it down at the bottom. Let's give that baby a swirl. It works better with spinach if you want it. Yeah, but look at that. Look at that pink glow. We definitely got some pink glow going on from the chlorophyll. Isn't that cool? Somebody said, please put base to a glow stick. We can do that. Let's do that. But there you go. We were able to get a little bit of pink glow from the chlorophyll from some tea. Interesting, huh? Somebody wants me to just mix the base with a glow stick. That sounds like fun. Let's do that. We're going to go ahead and do that. Let me get this cleaned up here a second. Just let me get this cleaned up. Let me get a new paper towel down. And we're going to do the suggested experiment. So what we're going to do next is we're going to get a glow stick going. And then we're going to add some base to it and watch what happens, okay? All right. Let me put this here so you have something to look at while I'm getting stuff ready. Here's our glowing chlorophyll solution right there. Turn this on. In the light, it's hard to see. In the dark, you can see the fluorescence, which is cool. Okay. So what color glow stick do we want to do? Looks like I got one that's got a red dye in it, although I don't know what color that's going to glow when it's on. Hey, that's great to hear, Pakistan. Football. This one I know will glow blue. This one here should glow like a yellow or a green. Thank you there, Sebastian. And I don't know what this one is. I got all sorts of colors. I can't tell which one's which. This one might be yellow. I don't know. So people want, I don't know what this one is. Kind of like a violet maybe. Who knows? You know what? We can figure it out. Let's just figure it out this way. We'll turn off the light. We'll shine the UV light on them. Oh, this one's yellow. That one there is green. This one here is going to be like a purple. There's my blue. And the other one is going to be a red. So green it is. Green is what everybody wants to do. You got it. So we're going green. That's this one here. That's this one here. So let's get these others out of the way. Get them out of the way. All right, let's get a cup ready. Let's get our cup ready. We're going to pop that right there. I'm going to fill it with some base. So there's the base. Let's get our glow stick glowing. There's that beautiful green. Look at that gorgeous green. Just an absolutely beautiful. Look how bright it is. So yeah, this particular dye in this glow stick glows a green color. I'm going to try to, unfortunately, I can't control the amount of light that my camera's picking up. Anyway, we're going to go ahead and pour it into this base, and we're going to see what happens, okay? So here we go. Let me go ahead and cut the top off. I don't want to splash stuff all over the place. Right there. Let's get this stuff out. It's beautiful. What exactly am I adding as a base? The base that I'm using is called sodium carbonate. We can get that here in the United States in the laundry section of many stores. It is sold as super washing soda. Okay, let's pour that stuff into the base and let's see what happens. The issue is, let me see if I can, let me just see something here. Can I control the amount of light here? What is this? Lighting on, lighting off. What's this? Oh, that's too much. Huh. I can't do it. All right, here we go. Let me go ahead and pour this in the base. Let's see what happens. You ready? Here we go. You guys okay? I'm seeing something's glitchy. Everything okay out there before I pour this in? I'm not seeing anybody saying anything. Okay, thanks, AE Master. Here we go. Thanks, Zesty. Okay, thanks, Star. Here we go. 1, 2, 3, and it goes. Look how much brighter that is, man. Look at that just taking off. Look at that stuff going. That is glowing so intensely bright. You can tell if you compare the glowing in here with the glowing in the glow stick. When I poured it in, look at that. It's just like, it's like the brightness of 1,000 suns. I know it's not that bright, but nevertheless, it is just absolutely taking off when it contacts the base, because bases catalyze or speed up the chemical reaction that's involved in glow sticks. And they actually add a base to the glow stick to get a, a brighter glow, but they have to they have to engineer it correctly, because if you add too much, as you'll see here, it does increase the rate, but that also means it burns out more quickly. A fire that burns quicker is going to burn out more quickly. It's going to burn more brightly, but it won't last as long. You got it, Laura. Come on, Laura, dropping the chemistry in the chat. You got it 100%. Nice thinking. Nice thinking. It's not going to glow as long. So yeah, that was kind of cool. Absolutely kind of cool. Well, what should we do next? What do you guys want to do next? You want to try another color? Trying another color. We're going to try another color. What color do you want me to do next? Thank you there, Zesty. Thank Laura. Put water inside? I'll put a little water in here. Watch what happens. Water usually quenches the reaction. So I'm going to add a little bit of water. Quenches means it actually quenches the fluorescence. So we're going to add purified drinking water. So this is pretty much just water. It's been purified by, you can see it says it right there. I don't know if you can see it, but it says purified water. So this is just water. There's been nothing added back. And we're going to pop it in there and see what happens. So I add a little bit. We're going to add a little bit of water. In it goes. And you know what? It doesn't look like it did a whole lot. Swirl it around. Doesn't look, yeah, I think it's dimming down a little bit. Oh, tonic water. I wish I had some. I don't have any tonic water, so we can't do that. But people are saying purple. We're going to do purple next. So give me a second. I've got to get another cup. And we're going to do purple next. I got to head back here to my plastic cup section of the lab. There we go. Purple next. So if I remember correctly, here we go. If I remember correctly, this glow stick is going to glow like a purple color. It's not perfect, but it's about what it glows. So remember, I'm going to add the super washing soda, which is sodium carbonate. Let's add a little bit of that. In it goes. All right. So there's the base. The base catalyzes the reaction. It speeds it up. It's going to speed up the chemical reaction. All right. So let's do it. Let's get our violet, or our purple, I should say, glow stick glowing. Let's get these out of the way. I don't need those anymore. Pour that over there. Okay. Here we go. Where's my, there it is. Okay. Purple glow stick glowing. Here we go. What if we add acid to a glow stick? We can see that next, all right? Hello there, Shane. There's your purple glow stick. It is really bright, y'all. I mean, it is like, it looks like a really bright pink color. To my eye, it looks purple. I'm sorry, I can't render the camera exactly what I'm seeing. All right. So now what we're going to do is I'm going to take the top off. Here we go. All right. I've got the top off of the glow stick. Remember, this container here contains base, and base speeds up the reaction in a glow stick. So let's see what happens on this one, all right? All right, let's see. Pour that baby in there, and let's see what happens. Look at it it looks like fire in there. It just kind of takes off as that base speeds up the chemical reaction. Look how much brighter it's glowing compared to the material that's left in the glow stick that I'm pouring out. The camera immediately adjusts, to the new brightness. But this is really glowing brightly, the stuff in the cup. The stuff in the glow stick is, by comparison, glowing a lot less bright. That's because these reactions are catalyzed by base. Catalyzed means speed up the chemical reaction, but it's not. Look at that. It looks kind of like the eye of the eye of the universe. Thank you there, Laura. Thank you there, Gooch. That's cool to hear, Laura. Thanks there, Zesty. It's like we're looking into the eye, like I don't know, a spiral galaxy or something goofy like that. Thanks, Zesty. Yeah, it is kind of fun. Definitely kind of fun. It looks like it's kind of petering out though, eh? Yep, it's definitely getting the glow is dying. Green worked a lot better. So yeah, drop the heart emoji color in the chat that you would like to see next. Now, for the record, I only have purple, green, red, yellow, and blue. Purple, green, red, yellow, or blue. Which one you want to see next? Purple, green, red, yellow, or blue. Drop the emoji heart of your choice in the chat, and we'll get it done for you. I'm seeing some blue from me and my cat. Laura says blue. Zesty says blue. Shane says red. Rosh and AE Master said, looks like blue is it. We're going to do blue, folks. That's what I saw the fastest. We're going blue. My crazy kid said either red or green. AE Master's voting blue. Zesty's voting blue. Here we go. Let's do some blue. Let's do some blue. Let me get a new cup out. Sebastian with the blue cold guy. Oh, man. Me and my cat saying blue. Okay. What if we add acid to a glow stick? Let's do that real quick. Let me get some acid real quick. I can show you. We can do this very quickly. We can do both, really. So I've got, let's see. Yep. Okay. Here we go. In this cup, we're going to put some hydrochloric acid. So in it goes. Got a bunch of hydrochloric acid in this cup. Actually, we can do it to this one back here. Might as well. It's already glowing a little bit, isn't it? Is it glowing enough? I don't think that's glowing enough for us to do the test. So remember, this cup over here has acid in it. Thanks, AE Master. Okay. And then you guys said it was blue. It was blue. Okay. So this one's going to have acid. This one's going to have base. I'm going to put the acid over here. And we're going to sprinkle some base into this side. Over here. That's quite a bit. Let me crunch those up. There's the blue glow stick we're going to do. Okay. Crunch these powders up just a bit. Thank you there, AE Master. Okay. Acid, base. Let's get our blue glow stick going. There we go. Nice and glow. Beautiful blue glow. Remember, base catalyzes this reaction. So we should expect the base, curses what just happened. Fortunately, that was shut. Ah! Too much going on here. So we should see the acid. Well, I'm guessing it's going to dim, and I'm guessing the base is going to brighten it, but you got to do the experiment. I mean, that's the guess, but who knows? Let me cut the top open. There we go. Try to keep the control in the middle. All right. Add a little bit of glow stick to the acid container first and compare the glow. And you can definitely see that the regular glow stick is glowing much better than in the acid container. In fact, in the acid container, the glow has gone out. It's not even working. All right, now we're going to do the same thing in the base container. Here we go. Let's put our glow stick fluid in the base container. And you can see it just glows so stinking bright. So bright by comparison. Look at it go, man. That's because, again, this chemical reaction that powers a glow stick is catalyzed or sped up by a base. Missy, I'm not going to eat it, but I can tell you that, you know, I've been experimenting with glow sticks for long enough that I once had a dog that ate some of it. Actually ate a glow stick. And it didn't hurt her, but you can tell she did not like the taste. Let's just put it that way. Thank you there, Laura. So, no, I won't be eating this. Hello there, Shujat. Very cool. I thought it might be fun to check out and see if we can get some different colors of glow stick by, I don't know, using some fluorescent markers. Maybe we could change, I don't know, like use a Sharpie or something like that. See if you can't change the color of a glow stick using a Sharpie. But in order to do that, we need to make sure that the Sharpie marker is fluorescent. Because if it's not fluorescent, it's not going to work. Glow sticks use fluorescent dyes. So I'm just going to test a couple Sharpie markers. We're first going to test to see if they're fluorescent or not. And we can do that using, of course, this is the UV light that I got. All right, this is what it looks like. So that's what we're gonna test it with. So let's see. I got this green Sharpie marker. I've got this pink Sharpie marker, and I've got this yellow Sharpie marker. And remember, we're going to use the marker dye. So we want to be looking at the marker tip because that's where the dye is going to come from that we're going to use to change the color of the glow stick. The dye that's used in the plastic casing might fluoresce, but I'm not going to extract anything from the casing. I'm going to be able to extract the dye from the tip. So keep that in mind. Hello there, Shujat. All right, so let's see. Let's see if any of these fluoresce. Boy, that's kind of hard to see. That's hard to tell. There's too much light for me to really tell what's going on. Although, I will tell you this. If you look closely, the tip of the green marker and the tip of the red marker both look dim. And this tip looks like it's bright and giving off light. Now, I'm going to do a second test just to make sure this is the case. And this is how easy it's going to be. What we're going to do is we're just simply going to draw a line on the marker that I have here on my table that I have, on the paper towel, excuse me. All right. And this should tell us if these are going to fluoresce or not. This is another test that we can do. I think this will be better. That other test, that was a little too hard to see. All right, so keep your eyes on those. We'll see if the yellow dye or the green dye or the pink dye fluoresce. Let's see. And then we can try to use it in our glow stick. So here we go. All I got to do is shine the UV light on it. You let me know what you think. Let's get this out of here. We don't want any extra light glowing on there. Holy mackerel, look at that. So, man, look at that yellow. That yellow is fluorescing like crazy. This one is also fluorescing pretty well. So the green dye fluoresces. This one, not so much. And this one is fluorescing pretty well. So what do you want to do? The yellow or the green? I think we're going to go with the green. I think we're going to go with the green. All right, so how am I going to extract this? I'm going to do it like this. Let's take that green marker. That was some interesting results. I'm going to take this green marker. Oh, Shane. Oh, well, Avani said green. Anyway, let's take this green marker, which we saw fluoresces, and I'm going to go ahead and just draw on the bottom of this cup here like this. Just draw a bunch, try to get a bunch of green dye on the bottom of the cup. Whole bunch of green dye. All right? Try to just color it in there. So we got a bunch of, just trying to put a bunch of dye in the cup. Keep moving it around. There we go. And just to make sure that it fluoresces, yeah, this should be fun. Let's turn this upside down just to see. Shine the light on it. Oh, yeah, look at that. That lit up like a light bulb, okay? I could mix them. All right, Daniel, let's mix them. Good call, Daniel. Let's mix them in there. Let's get a little green, yellow in there with the green, all right? Good call, Daniel. So we're going to put a little green in there as well. Excuse me, yellow in there as well. Mixing the dyes. Good call by Daniel. Mix them up. All right, let's see what that looks like now. Look at my marker, though, Daniel. Come on, Daniel, you messed up my marker. I got green and I got green and yellow together. Okay, it came off. It came off pretty well. All right. Let's see how this looks. Hello there, literal. Oh, yeah, you can see all the gunk that I drew on there. That's kind of fun. Okay, now we're going to try to extract that dye. The way I'm going to do that is I'm going to take a little bit of acetone. So what is acetone? I buy it at the, this stuff. I buy it at like a hardware store, all right? So let's pour a little bit of this in here. Oh, man, look at that. Come on, man, there's like a major color change. That happens sometimes. So that what we're seeing there is what's called a solvatochromic effect. What the heck does that mean? What that means is it means that in this marker, the fluid that surrounds this marker is probably water or something else. And this dye is going to have a particular color when it's dissolved in water. But it's going to change if it's an acetone. That's all that means. The color chrome, so it's solvatochromic. So the chromic part means color. The color changes. Solvo, that's solvent. The color changes depending on the solvent. So that's what we're seeing there, which I think is kind of cool. Now we're going to take a blue glow stick and see what happens if we, mix it in with this dye here. We should change the color. We're going to add the base because remember, we see a bigger effect when we have lots of base around. So I'm going to pour some base in there. That's just going to help the reaction kick off and really get going. All right, let me get I got to get a fresh paper towel down here. All right, and then we'll get a blue glow stick going and see what happens. See if we can change the color of a blue glow stick, all right? All right, so here goes the blue glow stick, all right? Now remember, the color of a glow stick occurs because in the glow stick, there's a particular fluorescent dye. The dye gains energy from the chemical reaction that's happening in here, and this particular dye gives off blue light when it fluoresces. And we know this stuff here gives off a different color when it fluoresces. Did I just pour all the crap on the ground? I did. For crying out loud, I just poured it all on my sheet. Sorry. Dadgummit. What an idiot. What an idiot. Get to explaining stuff. Let's see if we got some. Here, let me see if I got a little bit in here. Yeah, that doesn't have much dye in it. That doesn't have enough dye. I'm sorry, everybody. I am so sorry. I got to try this again. So sorry. Okay, so we're going to put in the yellow dye here. Yeah, we're going to try again. My bad. So there goes the yellow dye. And this is going to fluoresce a different color than blue, obviously. Well, maybe it's not obvious. We can always test that. So in goes the yellow. And then we're going to do the green as well. So in goes the green. Whoop. Here goes the green. So we get a mixture of yellow and green dye that I'm trying to extract fluorescent dye from fluorescent markers. Just put a little bit of acetone in there. We probably are going to see the Salvato chromatic effect again. Yep, you get a nice shift to like a greenish color. Beautiful color shift. Heck, I don't know if this is going to work, but we're going to find out. We're going to find out. Let me just wipe this up. I don't want to mess up my light box here. Okay. So somebody, Grant King, the chemist, has entered the chat. TCPO, 246 trichlorophenol. That's the product, right? So that's the product. Well, you use rhodamine. Rhodamine's I can't remember. It's like a pink fluorescer, if I remember correctly. So the TCPO is trichlorophenyl oxalate. Here, let me show you there, Grant. Grant's bringing out the chemistry here. So trichlorophenyl oxalate, that's going to be this big molecule here. Okay, trichlorophenyl oxalate, 3 chlorines, that's your trichloro. Here's your phenyl oxalate portion. And it forms trichlorophenol. That's what the chemical reaction does. We don't want to get into that, though, unless people are interested. So let me go ahead and pop this glow stick open, which you'll notice is fluorescing blue. I don't have any plutonium, man. If I did, I wouldn't be doing that live, eh? Okay. All right, let's see what happens. Did I put, no, I didn't put base in here yet. We got to do that step. Nope, I got to add a little bit of base. So let's get a little bit of base in here to kick off the, there we go. What kind of seals you talking about, seal? Yeah, I think seals are good. You know, the kind that swim in the water. I think those are cool. All right, so we got a little bit of base. We got a little bit of a different colored dye. Skylar loves to store trichloromethane without stabilizer. Seal meat. No, I've never tried seal meat. Here we go. Here we go. Let's pour the blue fluorescing light stick mixture into the yellow and green fluorescent dyes. See what happens. Did we shift the color? I'm not so sure we did. I'm not so sure we did. I don't think those fluorescers were powerful enough to significantly shift the color of our blue fluorescer that's already contained in the light stick. That's a bummer, man. That's a dud. That one didn't work at all. Ah, got you that, Skylar. That's a dud, folks. I apologize, but that one's no good. Although, you know, we're getting some nice glow from the... No, there's not hydrazine in here. That one's a dud. Let me show you this. This is another cool thing you can do with fluorescence. If you happen to have like a UV light, a couple cool things you can do. You ever see these food colors? Some of these food colors fluoresce. So what's nice about these food colors? You'll notice here they say no artificial dyes. So what the heck is going on with these? Let's see. Well, it looks like the dyes in here come from, oh, look at this, made 100% with natural vegetable juices and spices. So this one right here actually comes from blue-green algae. This is actually a blue dye. You can already see it's fluorescing a little bit of red, even though it's a blue dye. Can you see it? Can you see how it's kind of like got a violet color rather than a blue? That's because this stuff actually fluoresces red. Let's see how that works. So I'm going to take just this natural blue food dye, and we're going to add a couple drops here. Let's do like 3 drops there. There's just natural blue food dye. We're going to go ahead and add a little bit of water. Where's my water? Come on, baby. Here's my water. Pour it in there. So yeah, you can see it's a blue dye as expected. If you're carefully watching though, do you see some wisps of red in there? I do. That's fluorescence. So the red color you see is coming from this stuff actually gaining energy just from the room lights, just from the lights in the room and giving off red fluorescence. But here, it's easier to see if I shine the UV light on it. Check this out, man. Check this out, baby. Come on, look at how red that is. Isn't that gorgeous? That's off. All right. Let's see if we can just do it in the with the lights on. Nope. It kind of like looks violet when I turn on the UV light and then blue. You can see definite color shift. But it's much more dramatic if I turn off the light and then shine the UV light. Look at that, man. It's just gorgeous. I wonder if that fluoresces. I wonder if this stuff would fluoresce with the glow stick mixture. Let's find out. I don't know if it's going to work or not, but we're going to try it. So I think we're going to try this. I don't know. Here, we can just try it in the water first. If that doesn't work, we'll try it in acetone. Here we go. Pour this junk in and see what happens. Nope, doesn't look like I see red fluorescence. But what's crazy is it looks like I saw like a yellowish, like a yellow-green. Look at that. What the heck is going on? Why did that happen? I don't know. You know, I think maybe what's going on is, you remember we had the green and the yellow fluorescent dyes in? Do you remember that? In this mixture, you might remember, we got this going first when I took the green dye from a marker and the yellow dye from a marker, and they were in acetone. It looks like those dyes fluoresce a little bit better if the solvent happens to be water, which is what I poured in. Interesting. Hey, Tatiana, welcome aboard. I think that's what's going on there. I'm not sure. I mean, I'm not going to do a bunch of experiments to find out, but that was kind of cool. I think that's kind of cool. Right now, I'm interested in seeing if I can get this natural food dye from, you know, Watkins Natural Food Dyes. I'm not selling these. I'm just doing experiments with them. I just want to see if I can get that natural food dye to fluoresce in acetone, because it didn't look like it worked very well in water. So let's try it. I got a fresh cup. Let's add a couple drops of the blue food dye. 1, 2, 3, 4. All right. There's our natural blue food dye. Let's add some acetone. What's acetone? This is a certain chemical. They use it to like strip paint and stuff like that. I get it at like a hardware store. All right. Let's add a little bit of, where is it? Here's my acetone. I'll use it in here. Grant, I do use regular food dyes, and I've used some in experiments. They work quite well. So the red food dyes often, look at that, it doesn't even dissolve. Look at that, it does not want to mix. It does not want to mix with the acetone. It does not want to mix, man. Oh, brother, I'm not sure this is even going to work. We're going to try it, though. We are going to try it. But, yeah, that blue stuff does not want to mix with the acetone. Maybe if I add just a little bit of water. Let's add a little bit of water, see if we can increase the polarity of the mixture. See if we can get it in there. There we go. Just a bit of water. It is clumping. So if I add enough water there, we get a mixture of acetone and water, and then I can get the two to mix. I'm going to try to add just a little bit more acetone. Just a bit more. I wonder if it'll clump back up. I haven't mentioned polarity, Tatiana, but I'm pretty sure that's what's going on. So this is the dye in here is it's a protein. So that's, you know, proteins are finicky with what they're going to dissolve in. Anyway, let's put a little bit of base in there. Speed up any chemical reaction we might get with the glow stick. I don't think this is going to work, but we're going to try it anyways. So that's that. I just want to see if this is fluorescing now. Let's see. Oh, look at that. The fluorescence is pretty much gone. Like just the presence. Yeah, even I can see a bit of red, but I think it's going to be a dud. I don't think this is going to work. Look at how it's changed color, too. Yeah, I don't think it's going to work, but you never know. Let's try it. Who knows? Get a blue glow stick going. Why not? All right. Welcome back, AE Master. Where's my, here it is. Cut the lid off. Add it in and see what happens. All right. There's that. I think this is going to be a dud. That's my guess. But hey, I've been wrong before. I've been wrong before. All right, in it goes. Hello there, Daniel. Hello there, Phantom Gamer. Here we go. Pour it in. Dud. That's not glowing as well as it was in the glow stick. I think we got a dud there. No good. No good. Which flavor glow stick tastes best? Although, I don't know. I see a little bit of... I see some... you see a little bit of... Just a bit of like a purple fluorescence. Like, it's not blue, but it's not red, but it's more, you know, purple than it was before. I'm not going to say I'm sure, but, man, that does look a bit more red than it did before. Thank you there, Phantom. No, Star Dream. This is what I do is I take different dyes and see if I can change the color of glow stick. So I'm messing with glow stick fluid is what I'm doing here, not luminol. Here, let's show you. I think I might be able to get this to work with like the green and the these two. Yeah, okay, Phantom. I thought I saw some lavender too. Could I use copper oxide crystals? Tell me more. Tell me more, AE. I am unaware of how copper oxide crystals... You know what's crazy, folks? I don't understand how this happened. But look at that. That stuff is like looking pink now. How the heck did that happen? Because all I added to this was blue glow stick fluid and like the blue dye. It's just crazy, everything that's going on, man. There's a lot going on. I don't understand. That's why it's fun to play with all this stuff. Pour that in there. We'll take care of that later. All right. Let's try this again. We're going to put in, I'm going to color in here. There we go. Get some yellow food dye. Let's just put that user in timeout for 30 minutes. Somebody spam in the comments, so I just got rid of them. There we go. You guys couldn't see it because YouTube was holding the message for review. Just give me emojis with a bunch of obscene gestures on it. Okay. So, Seal, I wonder what would happen if you saturated large single-celled organisms like sailor's eyes algae and non-toxic and glow-in-the-dark material. You know, I apologize. I can't even comment on your question. I do not have the relevant expertise or knowledge to even give you an intelligent response. I apologize for that, but that's just the way that it is. I'm sure it's something very interesting, but I just cannot comment in a, intelligent way. Sorry about that. So let's see this. I've got some of the dye from a yellow fluorescent marker, some from a green fluorescent marker. I've coated the bottom of this cup with it. We're going to go ahead and shine a UV light on it, see what we see. Here we go. You can see, oh, yeah, that stuff definitely fluoresces, right? You can see we're definitely where I, coated the cup. I'm going to try now to pour some water in here to see if I can't extract the dye into some water. Hello there, Be Basic and Yondell. Welcome aboard. Pour that in there. Look at that. Yeah, we've dissolved it in some water. Very nice. Interesting. So, yeah, that must be, these markers are somewhat water-based. Very cool. Let's see what that looks like. Let's see if this fluoresces. That's after it's been extracted into the water. Oh man, look at that glowing. That is totally, look at that, it's just lighting up like a light bulb. That is remarkable. Whoa. Really, Seal? Platypuses glow blue under UV light. That's cool. Okay. Let's give it a shot. Let's get a blue glow stick and see if we can change the color of that thing. I'm running out of blue glow sticks here, folks. Hey, Shank. Appreciate that. Shank sent me, come on, Shank. Sent me $2 and a pack of Doritos. I love it. All right. So now let's remind ourselves what's in here. We've got, what do we got? We got a green glow stick, green fluorescent marker dye, yellow fluorescent marker dye mixed in some water. I'm going to add a little bit of base to this because that speeds up the chemical reaction involved in a glow stick. And this is a shout out to Shank M. This experiment's for you, Shank M. Hey, let's get this glow stick glowing. What's going on, Future Farm? Future Pharmacist here in the chat. I bet they've taken a lot of chemistry if they're a future pharmacist, that's for sure. All right, now, let us pop the lid off. All right. And then we're going to dump it in with the fluorescent dyes from a marker and see if we can't change the color of the glow stick. Nice to hear it, Future Farm. Here we go, baby. All right, I hope this works. Man, you can just see it fluorescing even from the blue light. Here we go. Let's pour it in there and let's see what happens. Oh, yeah. Oh, yeah. Come on now. Oh, man, look at that. We totally changed the glow of the blue glow stick. The fluorescent dyes from the markers have now taken over, and we have changed our blue glow stick into a green one. Isn't that fantastic? We controlled the color of our glow using fluorescent dyes. Now, you can probably see that the strength of the glow is dissipating. That's because I added the catalyst that makes the reaction go faster, and it also makes it die out more quickly. But that's really cool. That's a success. Earlier on, I tried this, but what I did is I used acetone to extract the dyes from the markers, and that didn't work. But when I extracted the dyes using water, it did. We changed a blue glow stick into a green one, baby. Thomas is saying it's still blue. Hey, that could be true. So the camera's not registering the color to you? Is that true? You all are seeing blue? Because I'm totally seeing green. I'm seeing green in the camera, too. I don't think so, AE Master. I do not think blue copper oxide crystals would work. It's teal, it's green. Okay, thanks. Okay, thank you. Thank you, guys. You had me thinking I was losing my mind. Okay. All right. Cool. Thank you for making me realize I'm not losing my mind here. Oh, that's funny. Make the eye drop so you can make your eyes glow at night. That's hilarious. Tom sees green, but his wife and Tom fights over blue and green. Yes, it is very low. That's because the catalyst sped up the reaction so much. Hey, Zagamir. Hey, at this point, I'm probably going to end the live. I'm going to turn the camera around just so you know to talk to y'all. I got a few things I want to mention to you. And, we just talked for a little while. So, yeah, we had a little bit of fun today, I think, doing some experiments. My understanding is most fluorescent materials have aromatic rings. That's pretty true. Hey, Future Farm. All right, let's flip this camera around. Let's do some talking. Got a little shirt that I made I want to show you guys. You can head on over to my you can head to my main page on YouTube. I know you probably can't. You probably won't be able to see this right. Here's the shirt. Instead of cool story, bro. Cool anecdote, bro. Now go collect some data. Don't you all get tired of people who, my uncle smoked cigarettes until he was 95. And he died at 95. And I just want to say, hey, that's a cool anecdote, bro. Now I want you to go collect some data on a bunch of people. The phone I'm using, I don't really know. Hey, Texas, that was fun. Yeah, the text is mirrored. I know. So, yeah, if you like this kind of goofy kind of T-shirt stuff, you can head on over to my main page, Tommy Technetium. I know this is backwards, too. Here, we'll flip it around this way. You get on over to Tommy Technetium. Check out some of my stuff. Check out my shorts. Maybe subscribe. Hey, man, we just hit 700,000 subscribers this morning. We passed the 700,000 subscriber mark, which is awesome. Got you there, Grant King. Sorry, man. Thanks, Future Farm. Appreciate that. Yeah. And if you're interested, if you happen to be like a science or a chemistry teacher, you might be interested in this too. You can find the link to this book. You can find the link to this book that I wrote. You can find that on my main YouTube page. I got experiments all over. That kind of the goofy stuff that I do. Yeah, let me show you this too. You might want to check this out. Chemical Demonstrations for High School and General Chemistry. It's a new book that I got out. You can, pick that up if you happen to be a science or a chemistry teacher. It might be something that you're interested in. But you didn't come here to see that kind of stuff. Let me just go ahead and talk to y'all, see what's going on. I do have a LinkedIn Future Farm. So if you do a little digging, you'll find out who I am. It won't be hard. And then you just send me an invite. Make sure you say your Future Farm so I know who you are, and we'll connect. That'd be cool. Do us a favor, define anecdotal. So, Mark, what anecdotal means is just a data point of one. So, for example, I have people tell me, hey, my grandpa smoked all his life and he lived to 95. And the implication there is because I have this one story where my grandpa smoked their whole life and they died at 95, the smoking's fine. I'm not going to have any problems with that. And I like to say, well, that's a cool story. Cool story, cool anecdote, bro. Now go collect some data. Just because one person did that doesn't mean over a large population that's going to be a wise thing to do. And that's what we do in science, right? We make observations and we say, oh, that's interesting. I saw it one time. Maybe I need to collect some more data to make sure this is really what I'm seeing. And when we do this, everybody knows, right? When you collect a lot of data on people who smoke versus people who don't, it does tend to be the case that people who don't smoke live longer and have less disease than people who do. So that's what I mean by anecdote. But go on, I don't want to say it's a statement without substance, right? Because, people's lived experience is their lived experience. You know what I'm saying? There are people who smoke their whole life, right? And they live till their 90s. But they're definitely the exception rather than the rule, right? For example, my uncle on my mother's side smoked his whole life, and he died at 72 of a heart attack. And he had 4 heart attacks throughout his life. My mom is still kicking strong at 82. And she's never had a heart attack. So, but I'm just giving you an anecdote. So, cool anecdote, Tommy T. Now go collect some data. What does the data say over a large population? Hey, thanks there, Mark. Oh, Marshall, I wish I knew. You got it, be gone. Yeah, maybe, Eduardo, maybe, right? Eduardo, that's funny, man. That's correct, Seal. Correct, man. A lot of valid and correct studies start out as anecdotes, but go collect some data, baby. Anecdotes don't cut it. Anecdotes don't cut it in science is what this T-shirt is trying to say. Anecdotes don't cut it. You gotta bring the data, man. You gotta bring the data. You start collecting data, you're making observations, put numbers on those observations. Now you're doing science. Yep, you got it, Texas time. However, if I'm a betting man, which, I am, I'm betting with my life. I mean, whether I choose to smoke cigarettes or not, I'm betting with my life. And because I am betting with my life, I don't smoke cigarettes. I try to eat healthy, try to live healthy. I get exercise and meditate and do all this stuff trying to just live a healthier, better life. You can't make a house by pouring the foundation, but you got to have one. I love that, Seal. What a great philosophical statement. Happy birthday, Layla. Yeah, how about it, man? Multi-vid, the vaping is rough. Vaping is definitely rough. Well, hey, folks, thanks for hanging out this afternoon. It's afternoon for me. I don't know what it is for all of you. Thanks for hanging out. Had a good time doing some live with you. I usually do the live on the weekend around this time, either Saturday or Sunday, something like that. Yeah, it was a good time hanging out with you all. I learned some stuff today, which was a lot of fun. Thanks, Texas time. Tell me about it, man. Eduardo, you must be a meditator. No, I'm not in California. I'm Eastern time zone. Yeah, it was fun. Sotos, maybe next time, all right? You're welcome, Eduardo. Thanks, there, Seal. Great to see y'all. We're going to see you next time, okay? Thanks for hanging out. Be always looking for the beauty around you, man. It's always there. And if you understand science, it gets a little bit more beautiful, too, because you understand sometimes what's happening. All right, folks, we're going to see you next time. Thanks for hanging out.